I run our government services division. We specialize in supporting complex and solving complex marine problems. Most of our work is with the government. The majority of our projects with the government are on DARPA or DARPA hard problems, where we're solving um, really cutting edge niche marine problems. We were a subcontractor to Envision on the original Muscle platform. We designed the mechanical structure and did all of the buoyancy calculations and energy calculations for uh, the power to lift the platform up and down, as well as supported the initial testing. We did some pool testing where the platform is raised up and down, and we were there to help ensure that the platform functioned correctly and was stable. We also supported the electronics and in later in the main trip where we went up and uh, helped understand what was going on with the platform um, to try to fix the platform. We were involved in the original design. We were not responsible for the electronics, but in the when there was an issue with the electronics in the main trip, we went and did a full system evaluation to understand which portions of the system were working correctly and which ones had issues. And we were able to identify several areas that needed to be corrected in order for the platform to function. There's several areas of risk in the platform. The primary being that because the oysters need to come out of the water to be serviced and aerated, the center of gravity of the platform raises up quite high, much higher than the previous muscle platform. And so platform stability at that time is critical in that we don't want to have the platform roll. And so there's a lot of very specific design features that are put into the system, along with control algorithms to stabilize the platform when on the surface. So that's certainly the number one risk. The number two risk would be the overall valve architecture to have seawater pump in and out of the system. The good news on that risk is that the way the platform is designed, we can always switch out valves with minimal to no impact. We can switch out valves in the field. The platform's designed to be field serviceable in that there's a number of line item replaceable units that if there's an issue that can be unbolted and bolted back on without engineering support. The kind of last of the major risks would just be overall system performance from an air and energy perspective, in that do we get the performance that we need with the proposed platform design, or during testing, are we going to find anything that we need more air or more battery, or need to tweak any of the subsystems. The testing program is split into two portions. The first is design validation, and the second is production validation. So in design validation, we'll take the first platform and bring it through a series of up-down motions in the water, taking on ballast to sink the platform coming up will induce tilt and verify that the platform can compensate correctly. We'll induce a few problems and verify that the software correctly identifies the problems and sends the messages back to shore. After that initial design validation phase, we'll switch over to production validation, where there'll be a smaller subset of tests that happen on every unit as they're produced to verify the valves are wired correctly, the software is correctly installed, and the tanks don't leak. Overall, without any schedule constraints, it would be a moderate to low complexity. there's a finite number of valves in the system and control points. And and so it's there may be a few software tweaks that have to happen, but overall the architecture is fairly simple. There's two seawater tanks, two air tanks, and there's six overall valves. And so it's just a matter of mapping out what the platform does in each of these behaviors and then verifying the mechanical structure performs as intended. It fits well. We have um, sufficient square footage in our facility to build up all of the system electronics, test them out, store the platforms prior to shipment. This is on the electronics and supporting hardware is much simpler than most of the projects that we worked on. And it's pretty streamlined from a manufacturing perspective. There's not a lot of touch labor involved per system. And so we can handle the throughput quite easily. Once the initial platforms are built, the longer term plan would be to continue, you know, making iterative improvements on the product design itself, and then helping to scale up to larger manufacturing. Whether that's all done by us or it's a split of us and others, um, kind of getting it to that point where we can really scale up. I view this platform as a pickup truck in that there's a lot of things we can do with it outside of just moving muscles up and down in the water. There's other enhancements, other value adds that we can engineer and add to the platform, and the architecture supports it.